One of the reasons that we actually have been learning about this NMM triangle, how to work out molar mass, what a mole is. The main reason that we're doing this stuff is so we can actually make predictions or work out how much of a reagent we need if we have a desired outcome. So let's say for some reason we needed exactly 5 grams of zinc sulfide. Well, I know that that's made by reacting zinc with sulfur. Now, sometimes you'll see sulfur written as S, sometimes you'll see it written as S8. If it's S8, you can think of it as a molecule. If you see it as S, that's basically that's simplifying it. All right, so I'm going to do it as S because it makes life easier. I know how much of this I want. Well, I know the mass of this that I want. So I need to know how much sulfur I need, and I actually need to know how much zinc I need. But I'm going to assume that I'm going to put too much sulfur in. So if I have too much sulfur, this is a reaction where I heat it. The excess sulfur will just burn off as sulfur dioxide, which isn't particularly good for us, but I can burn off the excess. So all I care about is how much zinc I need, because that's what we call my limiting factor. The thing that I need the right amount of, or I won't get my 5 grams of my product. So what I've sort of found is very useful when I've looked online and books is that a lot of ways this is taught is to treat the chemical equation as the headings of a table. So we actually turn it into a table. And what I often see written is N for amount is my first row. Little m for mass is often my next row. And MR, or big M, is my next one. And I quite like that because N equals little m over big M. That's actually the equation. This equals this divided by this. And when I put something over something, that means divided by. So it actually sort of gives me the triangle down the side as well to make my table. So my suggestion is when you're given an equation, and it's especially once you've balanced it, then turn it into, once you're given an equation, turn it into a table. Now the question asks nothing about the sulfur. So once my equation's balanced, this column is irrelevant. So I'm just going to put crosses in it so that I don't bother looking in there. Once my equation is balanced, that's irrelevant. The nice thing is I also notice that it's already balanced. 1 zinc on the left, 1 on the right. 1 sulfur on the left, 1 on the right. So we're pretty good for this one. I've used a nice easy one for you. Right, I also know a bit of information though. I know that I want to get 5 grams of the product, zinc sulfide. So I'm going to fill that in now. 5.0 grams. Because the question has said, how much zinc do I need to make 5 grams of my desired product, the stuff I want to make? I also have been given some atomic masses, so what will they help me find out? So what can I calculate from atomic mass?
The relative molar mass.
Fantastic. So I can find this value because I've been given these already. So the one for zinc is really easy. The atomic mass and the molar mass are the same because it's an element. So I just put that number into here. Okay. I can't just plug it into here though, because this has got a zinc and a sulfur. So how do I work that one out? This was our homework last night, what we were meant to do with it. How many zincs are in zinc sulfide? 1. How many sulfurs are in zinc sulfide? 1. So perfect, plus those two together. So I end up with 97.5 grams per mole. I think my maths is right there. Yep. Now, what I love about tables is if I look in a column and I've got 2 out of 3 bits of information, then I can find the third bit by using an equation. So what I also need to remember is my equation, is my triangle. What's missing in the first row for zinc sulfide? The amount. So I cover that and I get my equation. So I'm going to need to go 5.0 divided by 97.5. My answer there is 0.051282, blah, and it keeps going. Okay, I'm going to do it just to 3 numbers, okay, which is more precise than I need because I've only measured my final thing to 1 decimal place, so my mass of my zinc is probably only going to be good to 1 decimal place as well. But I'm going to go more significant figures than I need. I want to call it 0.0513. Moles. So I found this number out by using my triangle because I already knew these two. I found this one out because I've been given atomic masses. Okay. Now I look at my equation. Are there any numbers in front of zinc sulfide? No, so it means how many zinc sulfides? One. Are there any numbers in front of my zinc? No, so it means that there's how many zincs? 1 in the equation, great. So what we say is their mole ratio is 1 to 1. It means if I have 1 of those, I have 1 of those. If I have 10 of those, I need 10 of those. So if I have 0.0513 moles of these, how many of these do I need? Perfect, the same number. Okay, I'll pause there because that's the confusing bit, I reckon. If there's no numbers in front, or the numbers in front are the same. So let's say I'm going to rebalance it very quickly, just to show you. If it was that, which is also correct and balanced, it's still the same mole ratio because 8 to 8 is the same as 1 to 1. They both have 8s in front of them. Okay? So it doesn't, as long as the numbers in front of them are the same, you're just copying the number across. If the numbers are different, you divide by the first number, the one that you know, and you times by the other one. So if you want to do that in a calculator, you can check that I'm telling the truth. Divide by 8, and then multiply by 8 to get this one. Okay, and that would give me the amount of zinc, and it would be the same, because 8 over 8 is 1. Right, now when I look at this column, how many gaps are in it? Just 1 now. So anytime you've got something that's got 3 variables and you know 2 of the variables, you can find the third one. So I know N and I know MR because it's the same as AR, and I'm trying to find this. So I cover it. 2 numbers next to each other means they are multiplied. So I'm going to go 0.0513 times 65.4. And I get 3.3538. Well, guessing from what my answer was, I'm not precise beyond 1 decimal place, so 3.35 would be 3.4 grams. Because it looks like my scales are only good to that decimal place there. Alright? This, therefore, would be my answer. 3.4 grams of zinc would be required to make 5.0 grams of zinc sulfide. Because we normally do chemical reactions to make the product because that's useful. Alright? And that's sort of bringing together everything I've done so far, reintroducing you to that triangle, to that mole idea and how these two are linked, and should help you with finishing the work that I gave you for homework where it also asks the mass.
Why is that middle column cut out?
Why is it crossed out?
Yeah.
Okay, because the question hasn't mentioned sulfur at all. If it said how much sulfur do I need, I'd have to fill this one in as well, and then I'd have in this one an 8 to 1 ratio. So I have to divide this number by 8 to find the number of moles of this. So, seeing how you've asked it, let's do that one. Let's fill it in, let's see how much sulfur it is, but I'll do it in a different colour. Okay, so 8 there, 1 there. So if I made 8 of them, how many of these would I need? If I want to make 8 of them, I need 1 of them. Okay? If I wanted to make 16 of those, I'd need 2 of them. So what mathematical process are you doing there? You're dividing by 8. Cool, because this is 8 times bigger. So this number I need to divide by 8 to get this number. So bear with me while I do that. That is, I'm going to put it in standard form, 6.41 times 10 to the negative 3. I need to know this number here, which is going to be 32 times 8, because there's 8 sulfurs in one molecule. So 32.1 times 8, 256.8. And how do I find the thing in the middle?
Go M times R.
M.
MR.
Cool. And so I get basically 1.6 grams. So I'd need 1.6 grams of sulfur. Now I could have done that without any calculations. Does anyone know how I could have done that with no well, it's an addition or a subtraction. But actually I could have done that without doing all the maths here. I could have said, oh, if that's 3.4, that must be 1.6. How do I know that?
It adds up to 5.
Perfect. There is a law in physics and therefore chemistry called the law of conservation of mass. You can't make matter, things with mass, from something that doesn't have mass unless you're doing a creation event or, of course, the opposite, which is an annihilation event. So matter and antimatter meet, that sort of thing. All right? So because we're not working with that kind of thing, we're working in the nice realms of this planet. If you know one, and you know what it's got to add up to, you know the missing one. You don't actually have to do all the calculations around it. All right? So we normally wouldn't go through that whole process for sulfur. Any other questions before I stop the video? Awesome.